So this is going to be a tutorial on Ethers.js, which is a JavaScript library that interfaces with the Ethereum blockchain. So starting off, just generating a new account. You can see here that all that happens is the wallet object, the wallet class has a static method called createRandom, and it just generates a random account. So if you see that here, generate account, that's the code, and as you can see here, there is no interaction with either the blockchain provider, which is Infura in this case, or the actual Ethereum blockchain. It's just a key value pair. So that's how you create an Ethereum account. To get the balance of an Ethereum account, you come here, and this is the code. So if I was to run this, node t2 balance, you can see that working. So this is using Infura provider. So in order to get check your balance, you'll need an Infura account. If you don't have a balance, so just go to faucet.rankabee.io and you can get a balance of Monopoly money, basically. So I should have mentioned that what you saw there was Monopoly money. So this is just a test network, and the way to make sure you're on a test network is just when you're creating the Infura provider, it's just the first argument in that constructor followed by your Infura provider details, and so that means everything you're doing from there on with that provider is with the test network. So that's getting ETH balance. So you can see here the reason you need an Infura account. So what's going on here is you've got your Infura account details. You've already got your account that you've created and used Rankabee, the faucet, to add some value to it. And in the Ethers library, you're instantiating the provider, which is Infura. And then with that provider, you can add your account details. You can create a wallet object. And then with that wallet object, you can send a call to the blockchain, so to speak. This is probably slightly wrong in that the message Infura would have instance of the blockchain, the most recent instance of the blockchain state, and so it wouldn't have to go off and ask the blockchain to get the balance. It would already know that because at this point it would be static information. It's just stored information. And yep, so that flows all the way back pretty much instantaneously. So that's how the get balance works. To transfer Ethereum, so to transfer, you would just so here we've got a transfer going on, and it's fairly similar situation. So just the method you would use is send transaction, and tx would be an object with all the account details. So here in transfer ETH, you can see tx. I should probably rename that. So this is the object that you need to send, and all it contains is a to property and a value property. That's the functionality for sending ETH. Next down is creating a contract and sending it. So in the contract space, things get a bit hairier in that you will need to install Waffle. Is it Waffle? Truffle, sorry. You'll need to install Truffle. Where's the README file? I'm looking for README. Okay, so setup, you would need to install Truffle, follow Truffle, how they work, and you can run truffle compile, and that should create your contract artifacts, which are a bunch of JSON files. And the JSON files here is what we'll reference in the console applications. So once you've done the whole truffle thing, you can come into create a fungible contract here, this example here, and you can see that JSON file being referenced, and these are all the properties. The provider is instantiated as per normal, as is the probably this is new, is the factory. So Ethers has a contract factory where you pass in the artifact stuff, so that JSON file information, the ABI and the bytecode is passed along, and then as well as the wallet. And with that factory, you can deploy contracts. And special note here, this is the constructor arguments for the smart contract. So whatever you develop in your smart contract, if it's got anything being passed into here, there's where you want to put it. Oh, I've lost it, sorry. Yeah, here's where you want to put it, in the deploy statement. So that is creating a fungible contract. Transferring a token. You can see transferring a token. What's different here is you got the amount, you've got the contract and the wallet. So yeah, once you've got an account that's been generated, deployed, you want to keep the address and use that address, and here you're passing in, just to instantiate the contract, you need the ABI from the JSON file and the wallet again. And with all that information, you can go to the instantiated contract, and whatever method you've got on that contract. So here I'm using the transfer method, so that would correspond in the contract. Say here, you can't see it. I can't demonstrate that at the moment because I'm using OpenZeppelin libraries inheriting from them, so it's all abstracted. Actually, maybe I can. So if I go here, go to definition, yeah, cool. So if you're using OpenZeppelin, I highly recommend it. It's very cool. It does all the work for you. So yeah, here's the transfer method. So this is what we're using here is a call to the transfer method. If I can find where I'm at, from that was specified in the contract, and just passing on the arguments that are required for that. Here is so initially what you get back, it comes back as a promise, so you've got to do the whole async await, pain in the ass. And once you get back that, this is just the transaction receipt, it's not the actual outcome. Sorry, this is the signed transaction, I think. I'll have to do more research on that. It's something to do with it hasn't been, it's what is going to be submitted to the blockchain. The result of what was transpired on the actual blockchain, you need to again have an await function and a call to the wait method. So here's the actual result of that transfer transaction. So yeah, to try and explain that again, when you're calling a contract method, the first thing you're going to get back is signed transaction. So it's saying this is what I'm about to send to the network, or this is what has been sent to the network. And then you can use that result and just call it again to get the actual result. And it takes about a couple of minutes, no, a couple of seconds, 15 seconds, whatever it is. I'll probably explain that really badly, but there we go. So, so that's the transfer token. What else was I going to explain? So, yeah, just in some of these diagrams here. By the way, they're available here. I'll paste all the links below. Yes, you can see here, this is just a fairly generic, this is a voting contract, so this isn't ERC20 or ERC720 or anything. This is just, as you can see, the wallet's created first, then you instantiate the contract, and then you send the transaction. So initially, the signed transaction gets sent off to the blockchain, but Infura, all Infura is sending it back. I'm not even sure if it even makes it to Infura. But anyway, all you're getting back initially is the signed transaction receipt, or whatever it is. And then if you call wait, then that's when it goes all the way to the blockchain, and you'll get to see the result of what actually happened on the blockchain from that original call. That's the best I can explain it at the moment. This is all a work in progress, so I'm hoping to improve this, but at least you can keep an eye on this site as well as the my GitHub page, where I will have where I'll post all this information. So with those two things combined, that should hopefully get you guys started.